Alright, these are our notes for section 8.1 on angles and polygons, and before we get started there's two words that you need to know what they mean. First word, and you've heard these words before, interior means inside of a polygon, and exterior is obviously going to mean outside of a polygon. We're going to use those words today in this video, so make sure you don't get confused on what they are. You shouldn't. Those are pretty common words, but you do need to know what they are before we get started. Alright, first thing we need to know is a formula. And this formula is for the sum, which means all the angles added up, of the interior angles, which would be all the angles inside of a polygon. So if we added all the inside angles of a polygon up, this is the formula we'd use to figure out what that is. And the formula is S equals 180 times n minus 2, and n minus 2 is in parentheses. Now you gotta know what the S and the n stand for. The S stands for the sum of the interior angles, and the other important one is n, and it's the number of sides in the polygon. N is going to be more important because usually S is what it's going to equal. So you do need to know N. N is going to be, again, the number of sides on the polygon. We've got two examples here. The first one says find the sum of the interior angles of a, first one says decagon. Now you need to think back to last chapter when we talked about what the names of polygons were. A decagon means it has 10 sides. Okay, so our N in this case is going to be 10. So we're going to use a formula, S equals 180 times n minus 2. We're going to plug in what we know. 180 times 10 minus 2. 10 minus 2 is 8. So then we put in our calculator 180 times 8, and we get 1440. Now it is angles, so we should have a degree sign on our answer. And that's the sum of all of the angles added together. All the angles inside the decagon would add to 1440 degrees. The next one here is a 15gon. Now remember, if it's got more than 12 sides, we just do the number of sides dash gon, and that tells us how many sides it has. So this one in this case has 15. I'm going to use our formula again. S equals 180 times 15 minus 2 would be 180 times 15 minus 2 is 13. I'm going to put that in our calculator. 180 times 13, and we get 2340. And again, it's angles, so we need to have an angle, or sorry, a degree sign on our answer. Those are pretty simple. Those are pretty straightforward. All we're going to do is plug in n to the formula and simplify it. Our next example here is a little different. It's got an extra step to it. The directions say find the value of x and the measure of each angle in the polygon. Well, if we look here, we have a 5-sided figure, okay? And it doesn't tell us what the angles add up to, all the angles in the polygon. Remember, a 5-sided figure is called a pentagon. So the first thing we need to do is figure out what all the angles in the pentagon add to. So we're going to use our formula like we did on those first two examples. 180 times 5 minus 2 be 180 times 3. 180 times 3 is 540 degrees. So all the angles in the pentagon add to 540, and that's going to be the same for any pentagon, not just this one. Any pentagon, the angles are always going to add to 540. So what we would do in this case, we know that the 5 angles are 95, 102, 109, x, and 2x. And we've used this idea before. All of these angles need to add to the whole sum of all the angles in the polygon. So we would say 540 equals 95 plus 102 plus 109 plus x plus 2x. And we're going to simplify that. We can combine 95, 102, and 109. We can put that in our calculator, and we would get 540 equals 306 plus, there are really 3 x's here. X plus 2x is 3x. Now it's an algebra problem. It was an algebra problem before, but we just simplified it, so we're going to keep going. Minus 306 from both sides. 540 minus 306 is going to be 234 equals 3x. Divide both sides by 3. So x is 78. Now that's one part of our problem. Okay, it said to find the value of x and the measures of each angles in the polygon. So we have to take that x and plug it back in for the 2 missing angles. This one here is x, so it's going to be 78 degrees. The other angle is 2x. So what would be 2 times 78? 2 times 78 is going to be 156. And there are our 2 missing angles. Now, if you wanted to check, we would add up all the angles in the polygon, 78, 156, 109, 102, and 95, and they should equal 540. That's one way to check. All right, next thing we're going to talk about, we have a definition here, regular, and we've talked about what regular means. It means that all sides are congruent or equal. Every side in the polygon is going to be the same measure. Something like an equilateral triangle or a square. Those are examples of regular polygons because all the sides are the same. Now, if we have a regular polygon, we have another formula we need to know. And it's the formula for one interior angle of a regular polygon. It's just one of the inside angles, not all of them added together. To figure that out, we do use the formula for all of them added together, but then we divide that by n, by the number of sides, or the number of angles. Because the number of sides is going to match the number of angles. And since all the sides are congruent, all our angles will be congruent. So this is our formula to figure out one interior angle of a regular polygon. It's 180 times n minus 2 divided by n. Almost like that first formula, except we divide it by the number of sides. We've got an example. It says, what is the measure of one interior angle of an 11-gon? Alright, so we're going to use our formula. It would be 180 times 11 minus 2 divided by 11. It's going to simplify. It'd be 180 times 11 minus 2 is 9 over 11. Now notice that the top changes. That numerator in the set of parentheses, that number is going to change, but the denominator does not. It stays what n originally is. It stays 11. 180 times 9 is 1620. That's still divided by 11. And then when we divide 1620 by 11, we get 147.3. Now I rounded up. It's really 0.272727 repeating. So we rounded it up to 3. And that would be the measure of one interior angle. Alright? The next example uses this same idea, but it's asking you a different question. It says, if one interior angle of a polygon is 135, how many sides does the polygon have? So we're looking for something different. They tell us what the angle is, and we want to know the number of sides, which is n. We're looking for n in this case. So we're basically working backwards. We know that one angle is 135, and that's got to equal what our formula would be if we knew what n was. So 135 equals 180 times n minus 2 divided by n. We're going to simplify this. We're going to solve for n. First thing we need to do is multiply both sides by n. And what this is going to do is cancel out that fraction. So we get 135n equals 180 times n minus 2. Next thing we need to do is distribute our 180 through. So we get, move up here, 135n equals 180n minus 2 times 180 is 360. Now we're going to solve this like we normally would, solve it like an algebra problem. Minus 180n from both sides. That gives us negative 45n equals negative 360. Going to divide both sides by negative 45. So n is, we're going to put that in our calculator, negative 360 divided by negative 45. N is 8. Okay, means there's 8 sides to this figure. And an 8-sided figure, remember, is called an octagon. So we have an octagon here. And that's how we would solve it. You work it a little differently. You set your angle equal to the formula, and then you go back through and you solve for n. Alright, let's keep going. We're almost done. The next thing we have here is a definition, a vocabulary word. It's an exterior angle. For an exterior angle, you're going to extend the sides of a polygon, and the exterior, here's what it would look like. We extend one side. The exterior angle is right here. Alright? It's what's formed, and you can extend all the sides as long as you keep extending them in the same direction. Notice how I'm extending this to up or to the left. I extend this one the same way. It's out. I'm going the same direction. So this is what our figure looks like. And each one of these is an exterior angle. And when we have exterior angles, there's two ideas that we need to know. First one is that exterior and interior angles are supplementary. And if you remember back to last semester, supplementary means that they add to 180. Alright? So if we know the interior angle, we could just do 180 minus the interior angle to give us the exterior. They always add to 180. They're always supplementary. One interior and one exterior. The second idea is that is that all exterior angles of a polygon add to 360. And it doesn't matter the polygon. I could have an octagon, I could have a decagon, I could have a polygon with 25 sides. The exterior angles will always add to 360. It does not matter the shape. Exterior angles will always add to 360. Now there's one other thing. In a regular polygon, exterior angles are always congruent. Okay, but that's only in a regular polygon. If we have an irregular polygon, the exterior angles may be different depending on which interior angle we're talking about. But in a regular polygon, exterior angles will always be congruent. We've got one example here, and it says find the measure of an exterior angle of a regular 12-sided figure. Keyword here is regular. That means that all of our exterior angles will be the same. Now there's several different ways we could go about this. The easy way is to use the second big idea that the exterior angles always add to 360, and that if it has 12 sides, it's going to have 12 exterior angles. And since it's regular, they'll all be congruent. So what we can do is we can take 360 and just divide it by 12. And it will tell us what one exterior angle will be. Exterior angle is going to be 30 degrees because 360 divided by 12 is 30. Now, if we took that one step further, and this doesn't ask you that in this example, but if we took it one step further and asked for an interior angle, remember interior and exterior are supplementary, so we would just do 180 minus 30, and we get 150. Okay, that's taking it one extra step in figuring out the interior angle. You will need to know how to do both, okay? Not a very difficult problem. just divide by the number of sides, and then do 180 minus the answer that you got to figure out the interior. Now those are your notes for section 8.1. I will tell you that we are going to do a book check next time, and your homework is going to be book work, so you do need to bring your book to class for this next section. Okay, but those are your notes for 8.1. If you have questions, please bring them to class next time, and make sure you bring your book.